In this episode of Finno-Greek machining, we are going to make a nut for this rotating platform for multifix. At the moment I'm having here my test nut for M20, and we are going to make something which has more meat and which is also protecting the bearing at this end from chips, and has some handles in it. So, well, let's do it. Most of my projects seem to start inside the end of a shaft. This one is no exception. This is a 70 millimeter in diameter shaft, which I'm now going to cut with my angle grinder, and well, because it doesn't reach all the way through, I need to finish the cut with a hacksaw. Off the camera, I drilled and reamed a 16 millimeter hole into this piece. I also faced. And what I'm doing now, I'm drilling, boring a hole which is suitable for tapping M20 fine thread. It should be 19 millimeters. Well, I overshoot it a little bit. I don't know what happened. Here I'm boring a suitable pocket for the bearing housing. I'm using again the carriage hard stop, and I'm feeling half a millimeter at a time. And yeah, this is somewhat tedious. It takes some time to do this. In real time this took something like, I believe, an hour to go the whole way through. But you get finally done. But it's easier this way. You could do this radially, turning radially, but then you couldn't use the carriage stop, which is helping a lot in this case. The center of the bottom should be about 0.1 millimeter higher. This will prevent the bearing from rubbing once you thread this in. This bevel is here just to make it optically pleasing. There is no function for this bevel. off the scale. Well, I do this in order to be able to dial this in when I turn the workpiece around in the chuck. Tapping the M20 thread here. This thread has 1 millimeter pitch, and yeah, it's I must have the lathe in back gear, and then I just thread it in using wrenches. Normal tap wrenches wouldn't have room to rotate here, so therefore this adjustable wrench, and well, there is nothing wrong with this one if you have the tap follower, which keeps the tap straight. Placing packings in between the workpiece and the jaws. These are just some copper tube which I have flattened, and yeah, there you are. And then I'm using these parallels behind the workpiece in order to get it straight. Well, I just place them there, and then I tap this with my plastic hammer. Sometimes you need to tap it a little bit harder. This time, well, I'm tapping it until the parallels well, stay in place. So meaning that they are tight all over. I test them in each direction. This indicator stand has proven to be a real joy to use. Once you put it there, it stays there. And now I'm dialing in using the nice surface I made in the previous step. And well, it's quite easy to dial this in. Nothing fancy about this. Facing, well, I'm here, I'm just roughing it, getting rid of the irregularities on the surface. The next step, I will actually drive this very, very fast. It starts with something like 1200 RPM and ends up at about 2000. This lathe would be capable even more, but I'm afraid of doing this because I believe this chuck is not rated that high RPMs. There will be three handles in
this piece. And those are like sticks which are in a 20-degree angle. Well, therefore I make a bevel 20 degrees in order to be able to put them, and in order to them look like as if they belong there. Well, my dividing head is here in 20 degrees angle in order to get the holes in a 20 degrees angle. I will drill first with this 6.5 millimeter drill, which is the tapping size for M8, well, about that, and I will do 3 of these. After that, I have done all 3. I will then change to 10 millimeter drill, which I will be used to make a recess for the 10 millimeter rod, which has this M8 thread on the other end of it. Well, and after drilling with this 10 millimeter drill, I will just simply tap the holes. Well, this very strange way of putting your handle into tap is because I don't have much room left in the Z-axis. Actually, this tap wrench doesn't have room to go into that between the tap follower and the tap. Well, and the tap I'm using here is a gun tap. It means that it's pushing the chips into the hole. And this is the reason why I made these through holes, so that the chips can evacuate from the other end. Well, of course, this will spoil the M20 thread a little bit, but I will trace it afterwards when I have done these threads. Well, I have rounded the other end of this one in the bench grinder. It's a cutoff from a 10 millimeter cold rolled steel stock. And now what I'm doing, I'm facing it, and then I'm turning the other end to 8 millimeters in order to thread it with a die, and then I polish it, and after that I will actually turn it around and make the other end even rounder than it is, and polish that end as well. After that I will just put this into its place and tighten it there.
Well, again, we succeeded with this one. Well, it was actually quite easy to do this piece of metal. This material is otherwise very easy to turn, but it makes those birds' nests and those are really horrific. Other than that, well, yeah. So it fits quite nicely on that rotating platform. Let me show you. So let's take this test nut first away, like that. And well, now this has, it can be moved like that. But when you put the nut here, well, it has this recess which goes over this part, thus making the chips harder time to find their way into the bearing. And now when you tighten it here, you can preload the bearings with this one. Okay, and now there is a very small gap here. It's about 0.25 millimeters. So the chips, well, I hope that small gap will do some of protection for, and now you can rotate it with these handles, and yeah, very good, I would say. Well, the next thing for that one is to put a locking nut here, which locks the entire system in place, but that will be a little bit later. In the next episode of Finno-Ugric Machining, we are going to to deal with a thing called shop safety. This will be only for lathe, what can go wrong with your lathe, what you should not do with your lathe. Well, I have made a lot of mistakes with the lathe, and hopefully I have learned something from those mistakes. Quite many viewers have sent me warnings, not to do this, not to do that, etc. I guess I have been very lucky with this one. So, in the next episode we will be going through all my mistakes and maybe some more. Please put on the comments if there is something that you would really like to see. Well, I will not crash my lathe, but I will show you how you can do it very easily, actually. So, till then, keep safe, don't crash your lathe, and see you!